All right, we just got done talking about the graphs of a square root of x function and the cube root of x function. Now let's do a little bit with those cube root functions, and let's do a little bit of function notation, evaluating, and then let's do some simplifying. If you look at example number 7, it says for each function, find the indicated function value. For a, f of y equals the cube root of y, and they want us to find f of 125. Meaning, in our f function, if we input a 125 for y, what do we get as our output? If y is 25, what do we get as our output? That means we're going to substitute in a 125 for y. And what is the cube root of 125? What number multiplied by itself 3 times gives me 125? Did you say 5? So that means f of 125 is 5. It's positive, it works, everything's good to go. All right, what about b? If g of x is the cube root of x minus 1, let's find g of negative 26. That means wherever we see a variable, an x, we're going to plug in negative 26. So I'm going to take my function, I'm going to plug in negative 26. I ended up getting negative 26 minus 1, which is negative 27. Uh-oh. Are we allowed to have negatives underneath the cube root? Well, sure, because what number multiplied 3 times the same number gives me negative 27? What times what times what gives me negative 27? Did you say negative 3? So it's okay to have a negative underneath the cube root, just not a negative underneath the square root. So g of negative 26 is negative 3. All right, let's do some simplifying ones. If you look at example 8, it asks us to simplify the cube root of negative 8y cubed. So let's look at our variable, or not our variable, our coefficient first, negative 8. Let's figure out what number multiplies 3 times by itself to get us negative 8. And because we're underneath the cube root, it's okay to be negative. So what times what times what gives me negative 8? I got negative 2. And then we can look at our variable. What times what gives me y cubed? I said negative 2y. Now remember, when we were simplifying before and we had a square root, we had to be worried about negatives and absolute values. Do we have to be worried when we have a cube root? Well, let's check. Let's plug in a number, maybe negative 1, and see if the left side still equals the right side if I don't have absolute values. If I plug in a negative 1 to both sides, on the left side, I have a negative 1 cubed. Negative 1 times negative 1 times negative 1 is a negative 1. Negative 1 times negative 8 is positive 8. And the cube root of positive 8 is 2, right? Over on the right side, negative 2 times negative 1 is also positive 2. So it looks like we don't need absolute values anytime we're dealing with odd roots. We have to worry if they're an even root, but if they're an odd root, our answer should be okay without the absolute values. All right, let's look at b. The cube root of 1000t cubed. Ooh, a little bit of a bigger number. What times what times what gives me 1,000. And what quantity times itself 3 times gives me a t cubed. I ended up getting 10 and a t. Let's see if we need absolute values. If I plugged in a negative 1 on both sides, would it still be okay? Well, it looks like here on the right side, 10 times negative 1 is negative 10. Let's see if we get a negative 10 on the other side. If we don't, we may need absolute values. Negative 1 cubed gives me a negative 1. Negative 1 times 1,000 is negative 1,000. What number multiplied by itself 3 times gives me a negative 1,000? As long as I'm underneath the cube root, I can be negative, and it looks like my answer is negative 10. And negative 10 does equal negative 10. So if I put absolute values, I'd actually have the wrong answer, right? I need to make sure that I don't have absolute values on this one in order to make it true. So when do we need absolute values, or when do we need to worry about absolute values anyway? Well, remember, if it's an even square root, then I need to worry about absolute values. And if my answer is an odd exponent, then I need them. If it's even and my answer is even, then I don't need absolute values. If I have an odd root, then I don't have to worry about it at all. So I should be good without absolute values. And I need to make sure that I don't have absolute values to make sure that my answer is still true on those type of problems.